In this video, we're going to talk about material from chapter 5 in the Murach book regarding exception handling and input validation and sentinel values. So what these three things are: exception handling helps us to protect the program from errors or invalid input by the user, so we can capture those errors and prevent our program from failing or halting abnormally. And then input validation is we are often asking the user for pieces of input, but those inputs have rules. So if we want an integer value, for example, we want to make sure that they've entered something that's a valid integer. Maybe that needs to be a range, a positive integer, or some kind of range. Or if we want them to answer yes or no, or A, B, C, or D. And so we want to do input validation. We want to take the data that they entered and we want to validate it to be valid in the context of a program. And finally, a sentinel value will be a value that the user will enter that will tell us that they something special. So in this case, we'll be talking about a sentinel value: enter a number or quit or exit, something like that. And then that exit is the sentinel value. And so we'll have to write logic to be able to capture input, not knowing if it's the value that the user wants to enter or if it's the sentinel value that will tell us to do something special. So let's talk about exceptions first. You might have seen this because we've been doing input from the user, and we have been not doing input validation. So if we've asked the user to enter an integer, and we've just trusted them to do that, and we've been using the scanner next line, and we've been doing the integer.parseInt, and we've just been only entering valid integer data. But if the user were to enter invalid data there, that would have yielded an abnormal halt to the program. Would have thrown an exception, and you might have seen this in your code, and we've seen it once or twice in the examples. In this case, it's a number format exception. This is a formatting exception. The format of the number was not on the right. The number was not in the right format for whatever the code tried to do with this. So these are some methods that we're using frequently that might throw an exception. So parseInt and parseDouble, that's what we're going to be using mostly. And the number format exception simply says, hey, this string value, I tried to parse it into an integer and it didn't work. So I throw a number format exception. So we want to be able to catch those and tell the user, hey, we asked you to do something, you didn't enter it, try again. Okay. This is how we catch exceptions. We use a try block. So we say try all the stuff in this block, and then catch, if an exception occurs, catch it, and then do these statements. So if the exception never occurs, then the catch block never runs. Or if the exception, if some exception other than what we're trying to catch occurs, like some unexpected error, then also these statements won't run. So this is what it looks like in practice. We declare a value subtotal a double with 0. We then say enter the subtotal, then we do a try, parse double next line. So we've combined the next line and the parse all into one value here. Instead of doing next line into a string and then doing the string with the parse, we've done it all at once. And then we say if that is correct, then we print out the valid number. But we have this catch block here that says catch a number format exception. So this is a parameter definition. Catch, and then notice how we're using the parentheses. This looks like the parameter definition of a method. And so then we say what is the type of the exception. Number format exception is a type. It's a data type, just like string or scanner or any of those. And then we're going to name that exception E. So now we have a variable defined here. E actually has some methods and properties that we could print out if we were inclined to do so. We typically won't, but you could actually operate on E. It's going to be an object, just like any other variable in our code. So in this case, if the user enters something that does not correctly parse as a double, then this catch block will run, and we'll say, hey, you didn't try that. Now in our code, we would then maybe have this inside a loop, and we would go back and keep doing that. Here's that example in a while loop. This loop just continues. This loop just runs until the user does what we ask them to do. This is inside a method called getDouble. It takes a scanner and a prompt as parameters. Then it does a while loop while true. We print out the prompt. We collect the value from the user. We attempt to parse it. If it parses successfully, we return it and the while loop and the method end. If this does not parse correctly, if this line parse double does not parse and the user did not enter valid double, then we catch that number format exception and we say, hey, try again, and then we loop back and we do the whole thing again. This method, getDouble, we also have one for getInt. You should keep this because you will use this in most programs, getInt, getDouble, for the rest of the course. You're going to want to do this over and over and over again. So having this getDouble and getInt, these methods defined, you'll be able to use those, write them once for one application, for one assignment, and then be able to use them again and again and again for subsequent assignments. Because this code, if you want to get a valid double from the user, this is the code you need. So now if you have a method, you can just use getDouble. You can just call that method from any application to get that double value from the user. So writing these and being able to pull these up for future assignments, getDouble, getInt, get a double within a range, something like that. Those are going to be really key. So we're going to write those this week and next week, and then we'll use those over and over and over again. Here's one for getting a double within a range. So maybe I want a double value, but I want it to be between 100 and 200. So I can just pass in additional values here. And then in addition to doing the validating that it's a valid double, I just call my getDouble method that I've written. That's this one here on the previous slide. So now I know once this succeeds, I know I have a valid double. Now I can do a range check and see if it's within the range that I wanted. And if it is, then I return it. If not, then I can go. So this is input validation. I'm making sure that I'm using the getDouble method right here and using a try catch block and exception handling to make sure that the data that was entered by the user is a valid numeric double format. And then I'm doing additional input validation by saying it also needs to be between these two values. So this is input validation. I have input from the user. It's within the context of the problem that's trying to be solved. They need to enter valid information, right? If I ask them for side one of a rectangle, the answer cannot be banana. That's not a valid answer. So I have to be able to invalidate the input that they give me so that I can solve the problem and protect my program from bad data causing it to halt. So we see here, these are, I can actually name these the same. I can name methods, I can have two methods with the same name that have different parameter strings. This is called overloading. So if I wanted to do this, so I could name those two functions getDouble that we had here. This one is getDouble in range because it's got four parameters, a scanner, a string prompt, a min and a max. This one is called getDouble, but it's only got two parameters, the scanner and the prompt. So I can name them the same. I can give them the same name, but because the parameter lists are different, then they're going to be different functions even though they have the same name. Okay, we will solve this example in a subsequent video.